The Fairchild Republic A-10 Lightning Bolt, or simply the Hog, is one of the most iconic planes in the U.S. Air Force. A plane developed in the middle of the Cold War with a specific type of warfare in mind. If the Cold War tuned hot, one area was destined to become a battleground corridor of lowland. The U.S. developed an operational doctrine called air-land battle, and the A-10 was developed as a vital component of this strategy. A low-flying tank killer, which would work closely with the troops on the ground to break up enemy formations at the front, while high-flying bombers harassed the supply lines at the rear. The A-10 was a plane designed specifically for the role of close air support. Close air support is exactly that, close to friendly forces and close to unfriendly forces. It requires a plane to be capable of absorbing a great deal of damage as they come under fire and to be incredibly accurate where its weapons to avoid friendly fire. A plane with this role needs some unique qualities. It needs to be available at a moment's notice. In an ever-evolving battlefield, troops could need support without warning, and because of this the plane needs to be nearby and ready to go. This means working from forward bases that may not necessarily have all the infrastructure and equipment that other planes need to operate. Its survivability needs to be best in class. Flying this close to the ground is going to result in every man with weapon taking potshot at the plane. As a result, the plane needs to be capable dealing with small arms, machine guns, anti-aircraft guns, and even missiles. A future war between the Soviets and the US was expected to be won by whoever could out-manufacture and maintain their equipment. This plane was intended to be a cheap and rugged warhorse. It needed to be made with readily available off-the-shelf parts, so maintenance crews could easily interchange parts to repair damage quickly and at a low cost. Contractors bidding for the manufacturing contract needed to consider all of these factors and design the entire plane around the primary ornament, which was chosen before the design process started. The General Electric GAU-8A, a gun whose sound is so recognizable it has become a meme. The gun takes up a significant portion of the plane's internal volume at nearly 6 meters long, fitting snugly below the pilot. The largest part of the gun is the ammo drum, which typically holds 1,150 30mm rounds. The rounds are delivered to the 7 rotating barrels along a linkless chute system, which also pulls the shell casings back into the ammo drum after firing to prevent the expanded shells from damaging the plane. The belt system and rotating cam firing system of the barrels are both driven by a hydraulic motor, which is powered by 2 independent hydraulic systems on board. There are 2 separate hydraulic systems to ensure redundancy in operation, and both run the gun. The left and right hydraulic systems are pressurized by 2 identical engine-driven pumps on the left and right engine. If an engine is lost or one of the hydraulic lines is broken, then the controls powered by those hydraulics cease to work. However, the plane has been designed to allow it to continue flying on only one hydraulic system, as both elevators, both ailerons, and one rudder have hydraulic power. After loss of either hydraulic lines, ensuring powered control of pitch, roll, and yaw. Even after the loss of a single hydraulic system, if both are lost, the plane can switch to manual reversion flight control system. The GAU-8 Avenger is a monstrous machine designed to wreak havoc on those Soviet tanks attempting to push through Allied lines. To do this, they need heavy armor-piercing rounds. Are rounds made of aluminium with a depleted uranium core. Uranium is insanely dense at 19.1 grams centimeter cubed. In comparison is 11.3 grams centimeter cubed, and iron is 7.9. This density gives the round more kinetic energy for armor piercing. The depleted uranium also ablates material in a way that self-sharpens the projector, while tungsten, which is slightly denser than uranium, tends to mushroom out and dulls itself upon impact. There is currently 700,000 metric tons of depleted uranium stored as uranium hexafluoride in huge storage cylinders across America, costing uranium enrichment facilities a great amount in maintenance.